afternoon. So I'm Tim Verreke, and during the next 40 minutes, I will basically talk about some best practices. I want to share about how to tune Akamai for performance, offload, and operational efficiency. On the previous slide, you saw I work for Akamai, but I also own my own company, scalemates.com, which is basically a website for scale modelers, like building plastic cars or plastic. Oh, the lights are hurting. I'll go stand here. Yeah, that's better. Sorry. So basically, building plastic scale models, cars, planes, boats, etc. And so that's the website. Now, this is how the website looks. So basically, we have a product database with more than 250,000 of these scale models, and modelers can basically create projects, and it's also a social network. Now, when you look at the website, it has very long tail content, so more than 250,000 products, and some of them are only visited once every month, some of them maybe never. It's image heavy, so scale modelers can post their own pictures of their models. It needs to be good quality. Like, it should be pixely, it should be large images, and it has frequent ad hoc updates. So it's community driven, so everybody can make changes to the database, which means, let's say from a caching perspective, stuff can get out of date pretty quickly. And then it has a worldwide audience, so it's not just, let's say, in Belgium, where I come from, it's a global audience. And although I love performance, although I really do everything, let's say, from front-end optimization techniques, tuning everything, have great rates. Still, when I measured the performance of my website across the globe, and I, for example, visited Singapore 2 years ago, I said, oh yeah, great website, but it's slow. And that really hurt. Like, you spend a huge amount of time tuning for performance, and the only feedback you get is, the website is slow. And then in May, so I tried different CDNs, many different CDNs on the market. And the good thing is I work for Akamai, so I was in May able to move my website to Akamai, and then learn like what would be the result. And here is the result. So before and after. And basically what I would like, it also had a good impact. Performance had a good impact on bounce rate, has a good impact on page views. And so basically, during my talk, I want to explain how to get there and share some best practices. There are multiple sections. So first, we'll look at how to tune the end-to-end flow. So basically, from end user via Akamai to the origin. There are some key settings you really need to check, which can impact your performance. Then accelerating super dynamic content, either long tail, which is cacheable, but where caching might not actually make sense, to very dynamic content, like people making changes or transactional things. I have a lot of third-party tools, so some smart optimizations I did there. And then the last part is I implemented responsive images and sharing some best practices. Now, key thing is it's about tuning. Before you start tuning, make sure that you can see the results. So let's look at some of the monitoring best practices before we dive into the rest. So this is the offload of my website after a few days. Is this good or is this bad? It depends. It depends. If this is a 100% static website, then this is bad. If your website is 80% dynamic content and 20% cacheable content, then you can never get more than 20%. So this depends. Now, I've seen many customers who have basically one CP code for their 1.5 petabyte of traffic. And whenever you make a change, there is so much noise that you can't see like what was now the impact on the change I did. So the first thing is split your traffic into segments, and not just domain X, domain Y, domain Z. Split it, like for example, I did here. I split it by assets, so CSS, JavaScript, font files, and there I expect offload of probably 100%, right? All the images, albums, articles, avatars. Why did I make the split there? Because some of them are really long-tail content. The avatars are not long-tail content, and I want to have maybe different caching strategies for them. And I want to see the result whenever I make changes. Another key thing you see here is add some naming conventions. I've seen many CP codes called DSD1, DSD2, or the name of a domain name, and there are 70 other domain names on it. So add some naming conventions. It's just a label, so you can always change them later on. You can call it blah blah or 123, but make it something meaningful. The same reporting in Luna is suddenly like, hey, it's easy to drill down. I know what to look for. It makes sense. And this is then the example. So this is a subset of my traffic where I wanted to tune. And you see I made a first change. Oh, yes, I see a small improvement. Next, I made another change. And then that was a bit too, that was a bit, let's say, too heavy. And I made another change, and this is the final result. Now, this is maybe only 1% of my traffic. So if I didn't do the split in the CP code, I wouldn't have seen the difference in the full offload numbers. I would go from 80 to 80.1, and you don't know, like, is it just good luck or is it a good change? Organize your configs. That's what I always do is I group all the different settings in my property manager in similar logical groups. That makes it easier to find whenever you want to make a change. So back there. And I also include all the default rules. So there are many, many default settings in Akamai. I also include them in my configs. Why? Because I remember then, oh yeah, Akamai does this for me. Also, when you need to talk to colleagues, you can talk about, hey, this is all the stuff which has been done, right? Now, I showed this one slide. What does this slide say? Performance improved with 50%? Something like that? Many of us, let's say, work with averages. So I think averages are not good. And also a single measurement here. This is now the 50th percentile. So 50% of my users are faster than this value, but 50% of my users are also slower than this value. So for example, here you see the percentiles. So that's the graph you saw before. So in the middle, you see the drop. Now, depending if you look at the top 10% of my users, Akamai didn't make a difference. Who are the users? Those are all the users which were close to my origin, and there the difference didn't make the difference wasn't that big. But from here to here, that's 50% of the users. So 50% of the users were from 0.5 up to almost 2. So depending on how you measure, where you measure, it's perfectly possible, like, hey, I made some changes and I don't see a difference. I made some changes and oh, the difference is like neglectable. I will not do it. Always measure everything. Because what is this block? These are mainly the users in Australia, which had very, very bad performance. And now with enabling Akamai, it improved super better, right? This also means that if you just look at the 50th percentile, if you made a change and it impacts 20% of your users, and they happen to be in let's say, the worst 80%, and you measure this, you don't see, you might say, hey, it didn't have an impact, right? So let's look at tuning the end-to-end flow. Tuning origin connectivity. So the connection between the edge server and your backend. We need to do a DNS lookup, right? The DNS lookup has a TTL, let's say every 3 hours. It means every 3 hours, a user comes to an Akamai edge server, and the first thing the edge server needs to do is a DNS lookup. Takes time, right? It's a dynamic request, an additional, I don't know, 20, 30 milliseconds on top of the first byte time. What does DNS asynchronous refresh do? You tell the Akamai edge server, if a user comes in and the DNS has expired, and it's not older than 3 hours, which is configurable, you can still use the old DNS entry while I update the new DNS entry. Result, flat performance. Now, 3 hours, I have 2 million page views a month, 20,000 visitors a day. But in some parts of the world, it's perfectly possible that the last visitor was at 11 p.m. and the next visitor in that country is at 7 a.m. in the morning. So that's 8 hours. DNS lookup. So for me, and I know this is not always possible, but from a performance perspective, the best thing is hard-code your IP. Then you never have DNS lookup issues. If you need to have a DNS, that's good. Now with fast activation, before we said, oh, you need to have a DNS because then you don't need to make a change on Akamai when your backend changes. My backend doesn't change every week. And if it changes, it's faster now with fast activation to make a change than to wait 3 hours for the TTL to expire. That's one. Persistent connections. So the TCP connection between the edge server and Akamai is persistent. And default, Akamai expects a timeout of 5 minutes. So make sure that on your backend, the TTL is 1 second or 2 seconds longer. If you don't make a change, what happens? Akamai reuses the TCP connection, talks to your web server. Your web server says, I don't talk to you, you need to create a new connection. You spend time, and then you need to recreate a TCP connection. Keep alive 301. Now, many web servers also limit the amount of requests which can be done on the same TCP connection. And if you don't have a CTN, and you put, let's say, 200 requests, that makes sense because one user, 200 requests on the same connection, that's a lot. Now suddenly you have many users coming via the same edge server, reusing the same TCP connection. If you don't increase that value, that TCP connection has to be reutilized too often. And then you need to refresh, etc. So make sure this value is either unlimited or you increase it significantly. All make sense? Perfect. Tuning TLS. I suppose every website is now on HTTPS, so let's go for this one. The TLS Handshake, there are a few things which you can configure on Akamai which will speed it up. What you see here is the DNS lookup, TCP connection, TLS connection, so here the certificate is sent. And what's this? This is the OCSP check from your browser, which does a validation. Is this certificate actually still valid? And it needs to do a DNS request because it needs to talk to another service. It needs to do a TCP connection, and you get a response. What does this mean? A delay of 140 milliseconds on your time to first byte. Luckily, the browser is smart. He doesn't do that on every single request, but this happens frequently. Now, this was before I moved to Akamai. Since I'm on Akamai from a different location, is you see that as the Akamai edge server is close to all my users, the TCP connection is faster. I also moved to fast DNS, so this is the reason why DNS is faster. But here you see that we don't have this overhead because you can enable OCSP stapling, self-serviceable in Akamai CSP. Certificate provisioning system. It's just a checkbox. And what it does is Akamai will do the OCSP check for you, embed it in the certificate, and send it to the browser. So the browser doesn't have to do it. And if this happens on a mobile network with very high latency, the DNS lookup can even take longer. So enable OCSP stapling. And then make sure that you have the latest and the latest cipher sets, because Cha-Cha and Poly, they basically consume less resources on mobile devices to actually do the encryption and decryption. Just as well, easy, self-serviceable. Next is H2. Who knows this number? 1460? Sounds familiar? This is the amount which fits in one TCP packet, right? So if you need to send 1700 bytes, you need 2 TCP packets or 2 containers, right? If you need to send 6400 bytes, you need 5. If you need to send 5401, so you reduce your bytes with 10%, but you still need 5 containers. And you reduce it with 1 byte, and suddenly you only need 4 containers. Now, why did this matter in HTTP1? Because basically the amount of containers you needed is the amount of bytes divided by 1460, you round up. In HTTP1, it didn't matter if you make your request a little bit smaller. If you didn't save a container, there was no impact. So that's the reason, you shouldn't gzip below if its content is smaller than a certain value, because it didn't make any difference. Now, so every packet matters. So you tune for the amount of packets, not for the amount of bytes. Now we are in an H2 world. So let's give these things a bit of color. And let's say this is the HTML request, so you need 2 containers. And next is, instead of, HTTP1 was a bit selfish. Like, I know I have room in my container, but you're not allowed to join me. HTTP2 is much more friendly. Like, hey, I'll try to make some space, so as many of you can get in the same container, and we'll need less containers in total. Now, here, basically, you see we still need 2 requests. Now, suppose we do some tuning on this request. So you see it on the top. We made some tunings. Now, in HTTP1, this wouldn't have made any difference. In HTTP2, it doesn't make a difference on the purple one. It's as fast as before. But H2 is much more friendly and works in a group, so other requests can become more friendly. So in H2, every byte matters. Maybe not for that single request, but for the group of requests on your page. So that's also the reason when you tune for HTTP2, don't look at resource timing of a single resource, like, hey, I made a change, I reduced it with 400 bytes, and I don't see a difference. On a single request, it will not make a difference. On the group, it can make a difference. So what you should do, minify CSS JavaScript, that's default. Broadly compression, new compression algorithm, saves, on my side, 10–15% on all my CSS and JavaScript files. So that means I have 10 to 15% more space in my containers for other stuff. Remove headers. Any x powered by ASP.NET version whatever, or cache hits, or every header you send basically consumes bytes. Get rid of them. You'll have more space for the real bytes. So that's the end-to-end tune. So if you just do this, this will make sure that you have a solid baseline before you start tuning. So accelerating super dynamic content. I have many long tail pages. Pages change frequently, so how to tune for that? First question is, caching will typically increase performance. Caching increases scalability. Some of the settings you can do might increase performance, but decrease scalability. Some settings will increase scalability, but might impact performance. So the first thing you have to ask, why do I cache? Do I cache for scalability and I want to have the top offload numbers? Or can I make some changes? I maybe have 1% less offload, but I might have a faster site. So that's something you should ask yourself. Let me explain. Suppose this is fictional example. You have an edge server, and this is each time a hit on a certain object. Object, object, object. Suppose the object has a certain TTL. The object after the TTL has expired, this one, after TTL expired, what will this object have? It will likely be a bit slower. And depending on where you are in the world, that can be a small difference, or that could be a huge difference. So there is basically a performance risk. There's not just a performance risk, there is also a scalability risk, because depending on your TTL settings, you get more traffic to your origin. And there is a third risk, is if you increase your TTL too much, content might be out of date. So depending on the content, your content, you need to find the balance between being out of sync, making sure your website can handle the traffic, and the performance. So if I make my TTL longer, it's great for performance, great for scalability, but out of sync gets an issue. If I make the TTL too small, it's good for out of sync, scalability, etc. is bad. So that's one thing. Now, there is one super excellent key setting on Akamai, which you can work on, which removes many of these risks. And that's prefreshing. And I've not seen this, let's say, implemented a lot. So what does prefreshing do? Prefreshing, in my case, let's say in this example, after 80% of the TTL, the next request after that 80% triggers a request to the origin. But as the TTL is still valid, I can still serve that content to the end user, right? So that I didn't have a performance penalty. Now, the TTL shifts. That means that this request, which was normally slower, is now as fast as before. And then what happens there? Exactly the same. Result, performance risk is reduced. My offload will decrease with 10%. Because I'll have, instead of having, let's say, every hour one request, I'll have every X minutes a request. So based on your prefreshing settings. So what are the risks? If you make your prefresh, let's say 20%, you'll basically get a hit. You'll have a scalability issue. If you make this one too long, let's say 90%, and there is no request within that time frame, in the green time frame, the next user will come to the edge server and says, hey, I have an object, but it's expired, and you have a performance penalty. Make sense? Yeah. Sorry, if?
You have all the time traffic and you hit the page all the time.
Yes. Yes. So the question is, does it make sense to? It makes sense to have a high level. For hot content, yes. For hot content, if you're sure that you get requests within a certain time frame, you can increase the let's say the percentage. If, however, let's say during the night, traffic drops a bit, and for whatever reason you don't have a hit during 2 minutes times, for example, you have a performance issue. If you look at long tail content, that's an issue. And I'll explain it straight away. So this is an example. For example, on my homepage, I say during 4 hours, I want content in my cache. But after 2 hours, I already refresh the cache. So during the day, It basically means that every 2 hours, my content on the homepage is refreshed. During the night, when times, let's say when I have less visitors, I agree that after 3 hours and 55 minutes, that end user still gets the previous version instead of the new one. That's the trade-off I make. Now for category pages, they are less frequently visited, so they are had to enable 10 hours. Why? To make sure that I get over the limit, let's say the reduced traffic hours. Makes sense. Now, my product detail pages, they are very long tail. And what do I see there? Whatever caching setting I do with prefreshing, by the time the next user comes, the TTL is always expired. And as I have so low traffic, let's say on single, I have huge traffic on all the product pages together, but single pages is like very, very low traffic. Adding caching actually decreased performance. Why? Need to check the Akamai Edge server, it's not there. I went to the tier distribution server, it's not there. I went to the origin, etc., etc. So what I decided for my product pages is whatever caching setting I will do, it will hurt performance, so I made those dynamic. Although in theory, they are cacheable, so I made them dynamic. Now, next is you can look at certain objects, you can look at certain pages. There was a question? Yes? Sorry, I'll come closer to you. I can't hear you and I can't see you with the light. Sorry.
Simple, the TTL and the TSL, both handshake and the TTL time to you. It's going to automatically take the one more session because we are enabling refreshing, right? So it's going to refresh the page automatically.
Yes. Yes. Okay, I got it. Yes. So the question is, will the prefresh not automatically keep the cache up to date? That's, let's say, a key thing it doesn't do. What prefreshing doesn't do is automatically keep the cache fresh. It will only keep the cache fresh when a hit comes in, and when a hit comes in between the TTL and the prefresh time. So it's not, let's say, if you have no traffic on your website, what you would say is, hey, I have 10,000 objects in cache. When I enable prefreshing, Akamai Edge servers would constantly fetch to the origin to keep the content up to date. Prefreshing only sends a request to the origin within the time between the, let's say, the prefresh time and the actual TTL time. So if content is no longer requested, it's removed out of cache. Yes. Yeah. So could you make a request to all your objects to keep everything in cache? The answer is yes. In theory, yes. So let's say you set up in Site Analyzer a test to request all your pages. But if I do that, I have 1 million objects. If I need to fetch 1 million objects every X hours from multiple locations around the globe, I would, let's say, make Akamai happy because I would generate a huge amount of traffic.
We actually had this happen. One of our customers was disappointed with the performance of something that hadn't been released to production yet. And the reason was because the performance sucked.
Yes.
There wasn't any traffic there. So we did have to set up something initially just to kind of
fill
traffic so they didn't see that performance.
Yes. That makes sense, but that's basically to create, let's say, an empty cache to fill it. Yes. So what I also have like a yes.
Because it says that prefetch helps, but you still need to have traffic counts.
Yes. Yes. Indeed. So in my view, for example, for the category page, homepage, I have enough traffic, and I found the balance between TTL and prefresh time to basically never have the performance penalty. and always keep and always have, let's say, a reasonable updated content for the product pages. Even if I set it to 48 hours, or for some content 7 days, and I refresh it after 50%, if it hasn't been requested, it's not there. So for hot content, it's different. Yes, you? Yes, locally, yeah. So what I do, or what I'm thinking of doing is basically because in some regions I really have low traffic, like very low traffic, and even the hot content like CSS might not be in cache anymore. So what I am considering of doing is having like one page which includes all versions of CSS files, all critical and hot content, and fetch that, let's say, every hour from multiple locations around the globe, that at least the hot content is hot everywhere in the globe. But that's my case because in some locations I really have low traffic. But doing it on all content, yeah, in my case doesn't make sense. I have 1 million objects, doesn't make sense. Now, we have, you can, Greg, yes? To the browser, but I will talk about adaptive acceleration. Adaptive acceleration basically pushes to the browser, not to the edge server. Now, when you just look at single pages, you can define what are the best performance settings. Now let's look at my website. This is a newsfeed. I click on a product. This is one of the products, and this is one of the. Let's say this is a car, basically. Now, when you zoom in on this one, this actually shows how many users are currently live. My first issue I had was on the home page. I saw 170 users. I clicked next. I saw 179 users, and I clicked next, and I saw 190 users. So because there was a very dynamic piece on the page, the user experience was not good, right? Option 1 was basically, oh, let's just get rid of this. But then my bounce rate dropped because people thought I was a shop, and now they know I'm a social network, so I need to have it there, right? Now, option 2 was, let's make everything 100% dynamic, and then I don't have this issue, but then I have an issue with performance for some of my key landing pages. Option 3, which I implemented on my previous CDN, was basically, let's call this an XHR request. Everything is then cacheable, the base page is cacheable, and I call this an XHR request. This has one disadvantage, if you will see it. So I'm here on the newsfeed, and I click next, and then disappears. I click next, and disappears. So even though this Ajax request was requested, that I cached in the browser, I always had this popping up. And the perceived performance is less good. So the more parts are stable, the faster it looks. So option 3 was basically implementing ESI, edge server includes. So injecting that snippet in the HTML dynamically. And so let's look at that. The result is then, yeah, that's basically exactly that. You don't see a transition, and it's always the correct number. So even if it's updated, and it's at a certain point in time it becomes 121, all the next pages are 121 during a certain period. So basically, this is how the page looks. So all my web pages, the footer is exactly the same. So basically, I cached that one for 30 days. So all my pages get an ESI include of this footer. The header is, depending on the section, always the same. So the home page has a separate header, but all my 250,000 products have the same header. The content for the home page was 4 hours. Here, I decided this is dynamic, this is dynamic. And then the side box is the same for everybody again. And this block is also the same with 4 minutes only. So this is how I set up ESI, base HTML page, include footer, include header, include sidebar, include the online component. Now, what are the benefits? I can basically increase the TTL of my cacheable objects. My homepage, I was suddenly able to say, hey, it's up to 4 hours. Otherwise, the limit was 4 minutes. The most dynamic component defines normally your TTL. I was able to increase the cache efficiency by executing some logic. I also have, based on if the people, so my website is responsive, but people can still say, I want to enforce the desktop version that injects another CSS, other HTML. So I had 2 versions of my homepage everywhere in the world. I had 2 versions of my newsfeed everywhere in the world. So cache hit ratio even lower. The chance that you hit the prefreshing got lower. So now I basically execute this logic at the edge. So depending on certain settings, I just inject another JavaScript file or I remove it. And then reduce the weight of dynamic requests. So my product pages are dynamic, but I no longer, the footer on many websites includes many links, a huge block of content. The menu typically also contains many data. So basically, on the my dynamic requests, sending data from Belgium to Australia, I should send less data. I should compress on my server less. I should gzip less, so everything is a bit faster, and then everything is at the edge. So some of the results: increased performance and consistency. So when I click, everything stays stable, and the performance is fast. This is before, basically, and after. So that's one thing. And then the increased offload. So after implementing Akamai and ESI and all these different things, I use Datadog to monitor the traffic on my servers. And yeah, this is before Akamai. This is after Akamai. Also MySQL. Big drop. Also network, much less traffic which needs to be sent. I don't no longer have to send the footer, no longer have to send to sidebar. Everything, I have much more cache hit ratios. So that's one thing. From a timing perspective, how late is it? Can somebody? Sorry, I don't know how many minutes. Sorry, now 10 minutes we have left, I guess. No, 10 minutes left. Yes. Okay, good. I will skip this one. Tuck, 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 tuck. Now, advanced tuning example. Every website has autocomplete, and this needs to be as fast as possible. Have a good user experience. If I'm in Australia and I type something in, I need to wait 1 second to get a result. That's not good. Now, what is the chance that somebody else in another location has searched for the same thing? It's very low. So the more characters I type, the lower chance there is that I actually get a cache hit. So what did I do? I created when the search AC, this is my autocomplete, I created a variable. I calculated what is the length of the autocomplete field I filled in. And next, basically I say, if the length is 1, 2, or 3, like very low numbers. If I search for a car or a plane, and they also both start with AA, so the cache hit ratio on smaller numbers, some smaller characters, is higher than when you send more data. So basically what I say is, if it's short, I cache it for 24 hours. And here I also add prefreshing. All the rest is basically dynamic, right? Now, one of the issues is, you see here the amount of numbers and the perceived performance. So you have hit, you see 240, you click next, but I have very dynamic content. So people could have already added 2 additional Chevrolet Corvettes or have moved stuff. So basically, in order to keep the cache hit ratio good, I basically had to, for the lower numbers, I gave an indication of the amount of traffic. Controlling the cache is, I use Akamai CLI. It's very easy to implement it. And whenever I make a deployment, I use this. I know what has changed. For example, if I made a change to the footer, I know what has changed. I have for, let's say, depending on the change, I know it's always this list of files which need to be updated. I no longer have to go to Luna portal, copy paste. I just execute this command. Now, I also included in my CMS let's say, some cache management links. And depending on the user rights of the user, they can basically purge, let's say, the news feed. If they saw inappropriate content, they can, for example, purge it. But I also automated it. Like every website, there are spammers, in this case, Lady Kiss Kiss, who wants to talk with hot modelers. And so people can actually, I work for Akamai, so I don't have time to constantly be on the website. So when people can mark other people as spammers, there's like a mechanism. And when somebody is marked as a spammer, they're automatically removed from the database. But if I have a cache time of 4 hours on the newsfeed and their other content is all over the place, I basically automatically initiate a purge if a spammer was hit. Let's go a bit faster. Smart optimizations for third parties. This is adaptive acceleration, for example, is when you're in the airport and you need to go to security, which line do you pick? Shortest one? Mostly. But if you see in the shortest one, I have kids, don't go behind me when there are kids. If they're somebody you think are tourists, you probably won't use them either, because what happens is, although you know what needs to be done, they arrive, oh yeah, I might have money, I might have my belt, and they start working on it. And that's actually how a website also works. So you know that you will connect to Google Tag Manager, and when Google Tag Manager, it's time for Google Tag Manager, they say, oh yeah, let's do the DNS lookup. Let's do this, let's do that. What does Preconnect do is basically telling people in the line, make sure that you get your money, that you take off your belt. And this work has already been done. Now, how can this be enabled? With automatic Preconnect. I just enabled it on my website, and Akamai automatically, after a few minutes, started populating the Preconnects on my website based on file size. And this is how it looks. So here you see it connects to Impulse, it connects to Google Ads, it connects to TCP. Now, why are these not pre-connected? This banner advertising, so the banner can be from 10,000 different domains. So it only picks the ones which are used on all the pages. Third-party strategies is, before I had no CDN, and I used jQuery. Let's use jQuery on a CDN, right? Makes sense. Now, in my view, if you have Akamai, you should consider something. You should consider another strategy. Let's look at it. So this is, for example, the jQuery usage. And the same thing can be applied to any other library. This is just an example. So 750,000 of the top 1 million use jQuery. Like, hey, that's a lot. Let's use jQuery on the CDN, because the chance that they have it in cache is big. That's the reason. So you have these amount of sites using your library. Now, how many versions does jQuery have? A lot. So from the many sites, how many are using your version? Now, on how many different CDNs can you download jQuery? 4 or 5. So the chance that they have it in cache depends on your version, depends if they use, let's say, the same CDN for jQuery. And next, they need to have it in their browser. So that's one thing. Now, what are your possibilities? Option 1 is pick smart, like pick the right version, pick the right CDN if you want to do it, and do Preconnect. That would already be better. Yeah. Host locally for jQuery makes perfectly sense. If the version changes, the version swing changes. So that's like cache lifetime of 365. Now, for those third-party tools which change frequently, like every 30 minutes, every 60 minutes, you don't want to host it on your own. What you can do is you can proxy smart. So you can fake that it's on your own domain and say, if you detect, oh, I go to /static third parties jQuery, if you match on that path, go fetch it from cdn.jquery.com and add a TTL of which corresponds to their TTL. And then everything connects to the same browser. You have wordly compression, you have HTTP2, you don't need to do the DNS lookups, and you don't need to create a syncing mechanism. So that's what I, for example, do for the Impulse code. That changes potentially every 15 minutes, but this way my website is faster. Oops. The last one, how much? I think I need like 3 more minutes, if that's okay for everybody. So I can't compromise on quality, right? So the bigger the images, the better. The better the quality, the better. If I had like JPEG quality settings of 98, and still people complained like, hey, the original photo I updated, that little red does look a little bit pixely. So I always, my users complained about quality. But I like speed. So where to find the balance? So I implemented Image Manager. So with perceptual quality, I was able to, I said highest quality. I was able to send traffic, let's say, these big images, WebP format, reduced 30%, 40%, depending on the image. So that served a lot. Now, my images are used a lot on other websites. So they take the image, they copy paste it on a forum, and they start talking about it. And if that forum has a lot of visitors, that generates a lot of traffic. Before, my images were 1,000 pixels, okay, but I added responsive images, high retina screen, so my images were potentially 2,200 pixels wide, high quality. That ate a lot of traffic. Now, I didn't want to stop, I didn't want to block the images, so I didn't want to do something smart. So this is, for example, this is the default policy, so an image of 2,200 pixels, perceptual quality, high. Or for the rest, I didn't do anything. Now, if I detect that the request doesn't come from me or from my partner websites, I created a new image manager policy, hotlinked. And what does hotlinked say? Oh, limit the size to maximum 1,200 pixels. And instead of going for the high quality, let's go for medium high. And let's make some free advertising on all these different forums and add a small logo. So I also have a hotlinked CP code. I want to measure granularly what is the impact on certain changes. And since I did this change, so before I made a change, I added the CP code, waited 5 days to have some data, made the change, and the traffic dropped a lot. So these are the settings. So basically, 1,200 pixels. This is the watermark. I define like the scale. So I didn't want to have like a big. You can add a watermark which takes the full image. I still wanted to make it usable. And basically, in Property Manager, I say I only apply it if the referrer header is not ScaleMates, Railway Mates, or a German partner website. And then basically, I apply the policy hotlinked. And you can apply this for any other logic. The nice thing is, if I decide I change my logo, I just change the policy. I don't need to recreate all my images. I have 1 million images. Recreate all one image because I changed my hotlinked policy. So that's one of the things. So to summarize, importance of Luna monitoring, make sure you tune the end-to-end flow. Accelerate super dynamic content, when to cache, when not to cache. Prefreshing, check your prefresh settings. And then the rest, yeah, was covered just along. So I would say thank you very much for your time. And if you have more questions, you can answer them now, or people would like to leave. Of course, it's up to you. Thank you very much.